Now let me explain a description of each line of the control cabinet and the car roof. Now, see a plug-in panel under our control cabinet. The water cables are AA and AB, used to connect the car roof. Then BA is the shaft safety circuit. MT is the wiring for the brake. Then the bottom BD is the downward deceleration. D is an up deceleration. Then the OS is the speed limiter safety loop. W is a safety loop for the main machine to stop. What about BC? It's the bottom pit intercom. Then BB is our outbound communication cable and power supply. When we connect these wires, it goes up the hose to the roof. Soup after reaching the top of the car, usually we need to short. It's a backup. It's a safety switch. And then WT is one of our palanquin bottom scales. Light curtain. Then the door machine signal DEN 1. This is our safety circuit. SOSGS1 is a car door lock. DCE our car door power supply. EDP2 and DC2 are all from our back door. On the left is our front door man. Then our photoelectric switch. If we were two photoelectric switches, plug it in this re-diez. Its corresponding point is FL1. Corresponding to us is X1 of the main board. Then FL2 corresponds to our main board X3. And what if we had for electro-optics? You also need to plug a photoelectric on our DGS. Our DGS X9 and X10. The roof plate of our car corresponding to the X10. X9 X10. When we were adjusting the express train, first step, just check the deceleration lights of our X14 and 15 first. Now, our signal light 14 is not active. 15 signal light action represents where our elevator is now on the first floor. If your car is on the first floor, X14 needs to be bright. Then X15 needs to be extinguished. If the signal light feedback is abnormal, you need to check one of our deceleration switches. It is the BD and B we mentioned earlier. BD is up deceleration, B is down deceleration. Now let's test our flat layer sensor. Now we have 4 flat sensors. It's a sequence of 1. The first one, flat sensor, we should be the X9 of the car roof. And then a second flatbed sensor. We should be X1 of the main board. The third flat sensor is the X3 on our main board. Fourth planar sensor. It should be the X10 of our main board. If during operation, they measure in inconsistent order, need to adjust the sequence of our flat sensors. Now let's set our F5 group parameters. 501 upper plane. 5020 IV03 is the lower level. 04 is the door bypass. 06 is 38 operating contactor. Then 0739 brake contactor. Then 08 is 30 fan contactor feedback. Then 9 car roof maintenance and communication. 10 is the upper level. Overhaul uplink. Then 11 is maintenance down. 14 is up deceleration. 15 is the deceleration. 16 is the upper to speed change. Then 17 is the next to speed change. 18 is one of our brake feedback points, but we are now blocking the feedback point is X9. So let's change it to 0 first. Convert our F519 to 58. To 0 we don't need to worry. 21 is set to 27. power outage emergency rescue. Then 22, we set up a fire. 23, set up our host thermal. Our host thermal feedback point is X23. Our X23 is a normally closed point, restructured to 99. It is a long open and long close point of the signal of our car roof flat layer. Under normal circumstances, we don't need to touch it. 21 settings. 26 yes Y1 relay. Change to 1 to run the contactor output. Then 22 27 is our Y2 relay. Made to 2 is our brake contactor output. Then 28 is our Y3 relay. Is the fan contactor output. 29 is Y4 is our fire. Then 30, don't worry about these until it reaches our high pressure point X25. The F5 group parameters corresponding to X25 are F5 37.4, then 38.7. This is for the car door. The corresponding point is X26. Then 39 is 5. Then 40 we change to 0. Change F5 39 to 5. Our meaning is the hall door. Set him this point as the hall door. Then go first and now turn to our F60. Set our total floor. Our total floor is 4. This is set according to the actual number of floors on site. And now flip to our FZ40. Check if bit 1 is open. This is one of our soft limits. This must be opened. Well, the function of the soft limit is to prevent the elevator from going to the top or squat on the bottom. Put a limit on it. F6512 is bit 11 to turn on UCM-type communication. If you only have two photoelectric switches, we need to change this to 0. Then click Confirm. Suppose you have 4 photoelectric switches, and there is a UCM board. The UCM board is this model of D5. We just have to turn it on. Then it's a bit 6. Bit 6 is the top balance signal input. It is also when we have 4 optoelectronics, a parameter of the remake. Car top balance signal feedback is Zine and X10. If you still only have two photoelectric switches, corresponding to X1 to X3 of the main board, then we need to change it to 0. Okay, parameters complete. Now we start to adjust the express train. Turn this emergency electric switch to the service position, then the maintenance goes up. Observe our X1 and X3. Signal light. X1 and X3 are, the signal light is X3 to go out first, then extinguish after X1. Prove that our host is going down. Instead, I pushed the elevator up. At this point we need to change F to 110. The mainframe runs in the opposite direction. And now we're going to do one more step up. Watch us X1 and X3. X1 lights up first, X3 lights up later. Then observe our X15. The deceleration signal has been restored. Our car is going up. When the maintenance goes up, X1 always lights up first. X3 rear light. Now when we go down, X3 will light up first. X1 rear light. Domestic switch signal feedback must be correct. Otherwise, it will report E35. Good to reach the flat area. The deceleration switch also works. When the maintenance goes down, it lights up at 3 first, and then 1 after the other. And these are two photoelectric switches. There's a signal we need to look at. If you are 4 photoelectric switches, we need to double check. Our sedan roof balance signal, it's X9 and X10. Under normal circumstances, we overhaul and go up. It is always the X9 signal light that comes on first, and then light up a second time. Our main board X1, Then X3 lights up again, and then the last light that comes on. It's our main board, our car top communication version, one X10 and one signal light. If the signal is checked correctly, we can learn a fast train. Now for one of our express learning. For F1, change 11 to 3. Shaft self-learning. After confirmation, our overhaul control cabinet is overhauled back to normal. At this point, our elevator will go up. Pay attention to observe that our signal light 1 goes out first, then go out after 3. Keep going up, then 1 lights up first, then light up after 3, and as we do so, the elevator goes up. X15 down deceleration. Signal light has been restored. 1 lights up first, 3 lights up later. Prove that there is no problem with our photoelectric switch. At this moment, let's take a look at our car roof lights again. X9 lights up first, then X10 lights up later. Good to learn. After reaching the top floor, the signal light of our X14 will go out. Prove the action of the up deceleration signal. The elevator comes to a halt. Elevator opens. Prove self-learning success. Then after reaching the flat position,